All right. Hi there, everybody. My name is Mike Thompson. I am from AMD, and I manage AMD's global cloud product and business. And with me today, I have Madhu Rangarajan, who will come on. Madhu manages AMD's server product. So he's our vice president of server product, and we hope that you enjoy what we have to talk about today. So again, I'm Mike. Madhu is here, and today we would like to talk to you about AI on AMD in AWS. And the path that we will take there is to first talk about a little short introduction to AMD. What kind of products do we have, and how does that help technology in the world today? And then we'll talk about why AMD in AWS. Why should you even care about which vendor processor that you're running on? And it really does make a difference. It could be up to 45% of your spend or 45% of your performance. And then Madhu will come on stage to talk about the AI portfolio from AMD, because AI is about much more than GPUs. Because AI is the shiny new toy and GPUs have made so many millionaires, everyone thinks GPUs are required for AI, but in fact they're not. There's some aspects that you need them for, and we have GPUs for those too, but when a lot of people are looking to take their inference applications and launch them with the world, and they face access challenges with GPUs, having to sign up for maybe many years of promised spend, CPUs are an excellent alternative for offline applications that are not latency sensitive, as well as for small models and medium-sized models. They run just fine on CPUs. And so Madhu would tell you about AMD's portfolio for AI solutions and talk a little bit about CPU inference. So intro to AMD. So AMD is really a ubiquitous technology company. We provide support and technology that underpins social media, streaming, search, video conferencing, collaboration, as well as productivity applications. A lot of times as you use these, you might not see it, just like you might not see the processors that you're using in the cloud, but processor choice, technology choice really can have an impact on your applications, as well as how much money you have to spend on them, on your OpEx. And if we zoom in a little bit and look at specifically some data center products, AMD is first known for our CPUs. We have the highest performance data center CPUs on the planet today. We call those EPYC. And then a few people, when we were chatting today, you wanted to ask about GPUs. So Instinct is our GPU product line. That is for AI and HPC acceleration. That's been adopted by a number of clouds. We also have networking in DPUs. DPU is a data processing unit. Some people might call it a smart NIC. AWS has a similar kind of product. It's called a Nitro card. But these are used for offloading the processors from the overhead applications that take away from the real value generating application that you might be running there. So a way to do CPU offload for housekeeping type stuff, as well as FPGAs and adaptive SoCs, which are a very unique kind of computer chip that can be reconfigured. Whereas a CPU, we literally write the functionality in stone. When we etch the silicon, that's literally written in stone. You can't really change it. Whereas with FPGAs, you can fundamentally change the circuitry that's there. So AMD has a really broad portfolio of bleeding edge technology for a very, very wide range of applications. And one of the other things that can be surprising to some people, and this chart is actually the reason I came to work for AMD. I was working at Xilinx for a while, and when I saw this incredible market share shift that started happening in 2018, with our first generation EPYC, and we started getting more and more data center hyperscaler cloud adoption, particularly starting with the third generation. That's where I saw the market share shifting. And when I saw, geez, if AMD can move market share that fast against a 10,000-pound gorilla competitor CPU company, I want to go be part of that. And so with fourth and fifth generation EPYC, what we like to call Milan, you might know them by their nicknames. Milan is the fourth gen and Genoa is the fifth gen. That's where AMD's presence in the data center really, really took off. And so to capture over 34% market share in just the span of 5 years against a very, very entrenched leader in that space, they were a leader in that space, can be challenging to do. But because of the performance and the efficiency of AMD processors, these EPYC processors, we're seeing customers vote with their dollars. And a lot of people are unaware of this, so don't miss the boat. There is value there. Okay, and so next, let me talk about, oops, let me go back one. Next, let me talk about why you should care about running on AMD, why you should care about what vendor is supplying your processors. When AWS launched these latest generation of instances based on AMD EPYC processors, we call these 4th gen EPYC Genoa. AWS calls them their 7th gen instances. You got to look for the 7As. When they launched these, in their launch announcements, they said, we designed these to deliver the best x86 performance and price performance in all of EC2. Best performance, best price performance in all of EC2. The reason they were able to say that is because it was built on the back of a 50% generational performance uplift. So from our Milan 6th generation to our Genoa 7th generation, we see a 50% increase in 50% performance uplift, which is incredible. It's one of the largest maybe we've ever seen in server design in the last 25 or 30 years. That was accomplished through a combination of fundamentally two things. Of course, the processor itself has a really, really good architecture, particularly the cache architecture, the way that we're able to scale our resources as instance sizes get bigger compared to the competition where there's just more competition, more contention for the switching matrix. So a combination of EPYC's performance, the CPU performance, in addition to a collaborative server design that we did with AWS to make sure that the systemic elements, the system portions of the server don't starve the processor for performance. The processor is so high performance that you kind of have to think differently about your server design for I/O and such. So those two things, EPYC plus a collaborative server design, enabled us to get this 50% generational performance uplift. But why should you care? Like, what does that mean? Why should you maybe make decisions or think differently the next time you're going to land an application in the cloud or even on-prem, really? And so I want to show you some of those benefits. So the comparison I'm showing you here is M6i to M7a. So that is last gen Intel Xeon Ice Lake to current gen AMD EPYC Genoa. So one generation upgrade, modernization with the vendor change. And what that does is you get double the performance going from 6i to 7a. And so what can the performance do for you? Yeah, your application can run fast and everything, but it can do significant things for your bottom line because at double the performance, you need only half the number of instances to run your application, half the number of instances, or maybe half the instance size, particularly for license cost savings. If you cut the number of cores because you're doubling the performance, you get a dramatic return. And that drives a 37% OpEx savings. And one of the things you have to watch out for is a lot of folks who go to the cloud, and particularly that aren't real cloud FinOps savvy, they look at the hourly cost of the instances and they think that determines their true net job cost or their TCO. It really doesn't. Because if you have double the performance, you run with half the number of instances, half the size, or half the time, and that is dramatically lower cost. But at first, if you only look at the hourly cost, you might miss that. So consider the performance. And if you have an application that is not performance limited, we have another generation for you. So double the performance, half the number of instances, almost 40% lower OpEx to run on AMD simply by flipping the switch. You literally go into your console. I know stopping an instance is a big deal, but you stop the instance, you grab the instance selector dropdown, you select one with an A at the end, preferably a 7A for this kind of return, and you hit go, and that's it. It's not like you're porting to a different architecture and refactoring or something. It's very trivial by comparison. And so what does it mean to your bottom line? So as I go around the world talking to hundreds of customers and I read all the analyst reports I can get my hands on, this is the conclusion I come to. You know all the sexy applications that people want to talk about, AI, Gen AI in particular, advanced analytics and everything, that's all in the blue portion. That's only a third of your OpEx spend across financial services, healthcare, life sciences, bunch of digital native businesses, retail. Only 1/3 of their OpEx spend, infrastructure OpEx, is going into value generation, something that actually drives value for the business. 2/3 of it, 66%, is spent on what I call general IT overhead. So just the cost of doing business. Email, collaboration, employee management, that type of stuff. 2/3 of it's on that, but almost none of us spend any time working in that space. It's not as fancy, it's not as sexy, but there's a lot of money being spent there. If you take the minimum cost optimization that you can get from AMD 7A performance, you can get a 27% cost savings. This is not even an aggressive cost estimate. The average of all the big ones I've done is somewhere between 37 and 39%. But if you just optimize 27% of your general IT overhead, suddenly you're spending more than 50% of your OpEx on value generation in the business. This is how you can free up capital for those AI and ML applications that are popping up all the time that you didn't plan for at the beginning of the year and hence don't necessarily have funding for. Well, there's a tremendous amount of OpEx that can be optimized out of just overhead and reinvest that in value generation. And so that's what the performance can do for you. You have to think of it a little bit differently than maybe a traditional onboarding to the cloud. And so in a nutshell, basically what you could do, you cost optimize your general IT, you save 27 to 45% of your OpEx, and then most importantly, you can take those savings and reinvest them into growing your business or innovating by adopting these new novel technologies. And so that's the fundamental value for AMD. So there's 2 generations that you need to consider from AMD in order to be able to do that. On the left, this is the one we've been talking about. These are the 7th generation instances. They're powered by 4th gen EPYC, Genoa. They're the highest performance data center processors on the planet. We've got over 300 world records based on these. And with that, here I'm looking at a Redis database example where you have 2.2x the performance of the equivalent 7i instance, the equivalent Intel Xeon. And that drives almost a 50% lower spend. And so this is the Redis database. We did both set and get, basically write and read operations on multiple instance sizes and average that all together. But if you have an application that is not performance bound, if it just needs to run all day, maybe it's a login server looking to see who's logging in from wherever, you can't really scale, it just needs to be running there, you don't need to put it on the highest performance data center processor on the planet. We have the 6th generation instances, which AWS priced compared to their Intel counterparts 10% lower worldwide, everywhere except in India, where it's 45% lower cost per hour at the same or better performance. So same or better performance, 10 to 45% cheaper. That's good for the applications that need to run all day and really aren't CPU performance bound. So for hourly cost optimization, choose 6th gen instances. For performance optimization or for performance-driven cost optimization, choose 7th gen instances. And we have a very broad, robust ecosystem running on x86. It's one of the largest ecosystems on the planet. It's not going away anytime soon. If there's an application that runs on a computer, it most likely runs on x86. Can't say the same for some of the alternative architectures out there that might stay around. And so there's a robust set of tools and libraries there to support all of your applications and your development, as well as, we're at over 500 plus world records on AMD EPYC now. And so that's the value of AMD in a nutshell. And next I would like to invite Madhu on the stage to talk about AI on AMD. So thank you, Madhu.
All right, thank you, Mike.
Yes.
All right, so I'm going to jump into how AI works best on AMD. And before I get started, let me just kind of set the stage and zoom out a little bit. We already spoke extensively about leadership performance. Mike mentioned it quite a bit and gave you some examples. I'll dive into some examples specifically on the AI workloads. Energy efficiency is something you don't often think about when you're renting an instance from the cloud, but it does matter. If you have a data center on-prem, the benefits are clear directly to you because you can fit more servers in the data center and you spend less money on your power bill. But even if you're in the cloud, your cloud service provider is now hosting the servers, so you're indirectly exposed to that. You're exposed to that in the form of how much capacity can be available in a given location, how much the instance costs you, because power is a big part of the total cost of ownership. So even though you may not be exposed to energy efficiency directly, if you're renting in the cloud, it still matters. That's why price performance is best on AMD, because in addition to giving the best performance, we provide the best performance at the lowest power. And in terms of operationalizing AI, we'll talk about that a little bit. In general, the journey we see many of our customers take: modernize your infrastructure, reduce how much you're spending on all of your applications, reduce your footprint, and use the savings to invest in AI. Mike showed a great example of that earlier. And again, if you look at Epic, I'm going to give you examples of how we extend performance leadership with the M7A instances. I already spoke about the efficient modernization and the perf per watt, so I'll go briefly into a couple of examples on how we have leadership performance per watt. And then end-to-end AI leadership. I'll give you a few examples of workloads and benchmarks that speak to that. Okay? All right, when you think about AI technologies that have broad industry impact, the shiny object right now is what's on the right, generative AI. Everybody is talking about generative AI and LLMs. And while that's important, there are other use cases that are very broadly used. There's traditional machine learning used for fraud and cyber threat detection, used for many, many use cases. These are algorithms like support vector machines, k-means, and so on. These tend to be workloads that run on a CPU using vector extensions. So we'll give you some examples of how AMD CPUs do really well on those workloads. Second one is recommendation systems, used extensively across pretty much every industry you can think of. Whether it's social media or whether it's a shopping website, recommendation systems are ubiquitous. And I'll give you some examples of how Epic infrastructure can enable those as well. And of course, I'll give you examples of generative AI as well. So if you look at the spectrum of AI, there's training itself, which is extremely data and processing intensive. And this is where GPUs often excel. Even though you can do training in a CPU, if you really want time to train, get your models trained and ready for deployment in the industry, this is where you really want a GPU. And of course, AMD has the Instinct GPUs to enable that. But once your model is trained, when you're looking at inference, it's a little more complicated, right? You can run it on a GPU for specific use cases and deployment types. Or you can run it on a CPU for different use cases, and I'll get into some examples of when you should use a CPU and when inference really belongs on a GPU. But in addition to that, AI doesn't live in a vacuum, right? If you're providing AI services to a customer, you still have a web tier, you still have a memory caching tier, you still have databases, you still have storage, you still have all of those supporting services to support your AI services. And again, Epic excels at all of those workloads that support all of your AI services. Now, at AMD, we kind of have a spectrum of products, right? Mike spoke about a bunch of our products before. I'm specifically going to talk about the CPU and the GPU, the Epic CPUs and the Instinct GPUs. And I think unlike some of our other competitors, we don't really believe in saying CPU is the best thing for AI or GPU is the best thing for AI. We've got both. And for use cases where you want to do training, where you have dedicated AI deployments that are running at scale, where you have large generative AI model, large-scale real-time inference, things like that, a GPU is the best thing to use. And Instinct is a leadership GPU there. If you look at the MI300X and the inference performance on that, you'll see that it has the highest amount of HBM, and there are many workloads where it provides leadership performance. Now, if you go to mixed workload inference deployments where you have more traditional workloads mixed in with some inference, classical machine learning, which I spoke about earlier, and small to medium models, as well as if you're doing inference in the background, batch and offline inference, and maybe some small-scale real-time inference, the CPU works really well for that, and it's very practical for many real-world use cases. And that kind of leads you to, well, what's the advantage of doing inference on a CPU? First is availability, right? You bought a whole bunch of reserved instances. Those are available. You can use those for CPU inference. And in some cases, you want inference local to the application running on your CPU. So that's another good use case to run inference on a CPU. And in some cases, you may have LLM use cases where you're not like having thousands of users hitting on the server all the time. You have sporadic use cases. Think of an enterprise chatbot. So for those, we actually have large memory capacity on the host CPU, so you can have multiple LLMs sitting on the host memory at the same time and be able to answer those queries. Here's a practical example in the bottom. So this is a smaller language model. It's Llama 3.2 1 billion. And if your use case is, it's not like a inference serving server, but it's doing multiple things and also inference, and you have an enterprise chatbot running on it. For something like a short Q&A, where both the input token length and the output token length are pretty small, you can see that we get a pretty good time to first token, 200 milliseconds, and you get a throughput of 300 tokens per second, which is more than what a user can read at. So it's a very practical use case where, unless that's the only thing you're doing in the server, you can use that CPU to do that kind of LLM inference, or SLM in this case. Summarization is the other use case where you input a large set of tokens, and then you summarize that down to a smaller set of tokens. Again, in that use case, you can see that the time to first token is about 1.5 seconds. You type in, you feed in this entire document. It takes about 1.5 seconds. But after that, it's giving you the summary at about 100 tokens per second, which again is very acceptable to a user. So many use cases work very well on a CPU, and in many cases, since you already have the CPU, it's a good use case for the CPUs. Now, again, this is kind of rehashing what I said earlier. If you look at the spectrum of use cases, we spoke about machine learning. Decision trees and predictive text work really well on CPUs. I'm going to talk about some examples in the next slide. Recommendation systems and mixed AI is the other example. And we already spoke about generative AI, and we spoke about SLMs and LLMs. But I also want to talk a little bit about RAG. Right? RAG is very popular now with LLMs, where before you send a query to wherever you're running your deep learning engine, whether it's a CPU or a GPU, you want to augment it with some relevant information so that the answers you get are more relevant. And RAG runs really, really well on a CPU. And you can actually look up AMD's AI website and see examples of RAG and performance on RAG pipelines. So now I'm going to jump into some benchmarks. And what I'm comparing here, the first bar is Intel Emerald Rapids. The second bar is the 4th generation EPYC, which also known as Genoa. And the third bar is the 5th generation EPYC, also known as Turin, which is something we just launched recently. So you won't see instances available yet, but you'll see them coming into the market soon. If you look at something like XGBoost, which is a good proxy for a machine learning workload, more classical machine learning, you can see that Genoa, our 4th generation EPYC, is already beating the competition by about 1.2x. And when we go to the 5th generation EPYC, we are actually taking it to an entirely new level, like up to 3x better. The second workload there is TPCx AI, which is an end-to-end AI workload. So it includes things like data preparation and pre-processing, and it includes some matrix multiplication as well, but then there's post-processing. So it's not just the deep learning kernel matrix multiplication all by itself, it's an entire pipeline. And if you consider the pipeline as a whole, once again, what you see is 4th generation EPYC's already beating the competition by about 1.7x, and then 5th generation EPYC takes it to an entirely new level. And this is on the CPU bare metal, if you're running it, if you're renting a bare metal instance or have your own server. I'll also get into examples of, well, what does it look like when you rent an instance? Now, this one actually shifts to exactly that. So previously I showed you bare metal. This one is, now I'm renting an M7A instance, and I want to see how it does versus an M7i instance. So I'm comparing the same generation of AMD instance with the same generation of Intel instance across a bunch of workloads. DLRM as a recommendation system. And then we have a few small LMs. We have Llama 2 as a larger language model, and then we have GPTJ. And if you look across the board and look at perf per dollar, right, which is what most users care about, you can see that across the board, we are anywhere from 1.47x all the way to 2.4x on these workloads compared to the competing instance in the same generation. Okay? The other thing I wanted to talk about is, so the previous slide showed you how you can basically rent the AMD instance and get more performance. This one shows you how you can get the same performance by renting fewer instances and saving money, right? So if you look at this, right, if you rent an M7A instance instead of an M7I instance, you can rent a lot less instances and get the same performance out of it. And that results in anywhere from a 37 to a 44% cost savings. And the next thing I wanted to talk about efficiency, because as I mentioned, right, even though you may not care directly about efficiency when you're not running a data center, this is how the price performance comes out to be beneficial for you. So if you look at the efficiency of inference in terms of inference per CPU watt as a metric, you can see that we're anywhere from 1.2x to 2.4x better than the corresponding Intel instance. And all of this is before the 5th generation EPYC. All of these examples are 4th generation EPYC, and the 5th generation EPYC actually takes it to an entirely new level. So you'll see all of these bars go up significantly in the 5th generation EPYC. And again, if you look at Gen AI performance on, again, this is back to bare metal, and a perf per system dollar, if you're buying your own servers, you can see that we get anywhere from 1.17 to 1.21x the perf per system dollar on something like a Llama 2 7 billion or Llama 3 8 billion throughput. And again, in terms of how that translates into cloud, this is why you get much better perf per dollar in the cloud, because our bare metal infrastructure offers these kinds of benefits. Okay. Now, how do you take advantage of this, right? Do you need any special software stacks and so on? And the answer is not really. And Mike spoke about this earlier, right? AMD servers are really easy to adopt, right? It's x86. If you remember, for those who have longer memories, back in the day, AMD is the one that came up with the x86 64 instruction set. And all the x86 servers are running on that. So pretty much things just work. For example, if you are running your code on an Intel server using IPEX, and you take that stack and run it on an AMD server, it just works, and often the performance is better than what you'd get out of the competition. But you can get better than that, right? You want to start taking advantage of the hardware. We have the ZenDNN plugin. So if you are used to using PyTorch or TensorFlow or Onyx, you can use the ZenDNN plugin along with that. You don't have to change your application. You don't have to change your framework. You just use the plugin. And this plugin is going to do things like graph optimization and microkernel optimizations. I'll speak about those a little bit, and give you even more performance out of the AMD hardware. So step one is use your existing stack. It just works. Step two is, well, try out the plugin. It's easy to adopt, and you can get even more performance. Okay? And again, if you look at what we're doing with the ZenDNN plugin, it's open source, license-free, no vendor lock-in, and it's frictionless because that's why we came up with it as a plugin. You don't have to go to a different branch of Python or anything of that sort. You use the version of Python you care about, as long as it's a supported version, and then just use the plugin, and you get all of the performance benefits from doing that, and I'll get through some examples of what kind of benefits. And if you look at the ZenDNN advantage, if you use ZenDNN over just the whatever software stack you're using, you can get up to 52% performance across many AI workloads. Some NLP, natural language processing, and LLMs, as well as recommender systems. And we keep expanding ZenDNN to add support for more and more models and get more performant. And under the hood, what we're doing is graph optimizations and multi-threading and fusions that are tuned to the AMD architecture, right? How our caching hierarchy is, what our microarchitecture looks like. So ZenDNN takes advantage of all of that to give you the best performance, right? And in terms of the plugins, it's on GitHub. You can just install it with pip install. It's supported with PyTorch, supported with TensorFlow. And with Onyx runtime, ZenDNN is integrated directly. It's not really a plugin model in that case, but with PyTorch and TensorFlow, it is a plugin. And again, this is just a little more detail of what's under the hood on ZenDNN, right? You're supporting the frameworks on top, TensorFlow, PyTorch, Onyx, RT. You got the ZenDNN plugin one level below that, and what it's doing is graph optimizations. It's optimizing the patterns in the model graph and taking advantage of the microarchitecture and leveraging AMD's graph compilation optimizations. If you look at operator level optimizations, we're doing fusions, we are optimizing the memory allocations, so that improves your performance further. And all the way to the microkernel level, we integrate the AOCL library into this one, and what that does is makes the gems and other very basic microkernels of deep learning much more efficient, and that's what gives you the performance. And, well, what does that give you? So, to start off, right, let's say you are used to using IPEX or some other stack, and the red line there shows the performance normalized to the baseline. Let's just start with the stack that you already have. Then install ZenDN GenTorch 4.2 on top of that. You get about 20 to 30% more performance by leveraging ZenDNN. And this is across a bunch of different workloads, right? You have BERT large, you have GPT-2, you have GPT-J, you have Llama 7 billion. This is just some examples, and we continue to keep expanding the models we support on this. And this is a lot of words on the slide. I'm not going to go through all of it. But if you look at our ZenDNN roadmap, ZenDNN 4.2 was launched in April. That's the first time we made it a plugin. Until then, it was a branch. It was harder for customers to adopt. We heard our customers. That's when we changed it to a plugin. And that's when we have at least parity with IPEX and IPEX. And in many cases, like the previous slide, we have some models where we have performance higher than that. What we released recently along with Turin launch was the ZenDNN 5.0. And what ZenDNN 5.0 does is it supports additional versions of PyTorch and TensorFlow. And we optimize more workloads, right? We added Llama 3.1, Phi 3, Gemma 2, and a bunch of other workloads. And with ZenDNN 5.0, in general, you'll see 20 to 40% more performance over just using IPEX or ITREX as is. Okay. And this is just a summary of all of the different inferencing workloads on instances. So on the top, we have the HPC optimized instances. In the middle, you have the bare metal instances. And in the bottom, you have the typical M7 instances. And we're comparing all of this to Intel instances in the same generation, right? And in general, what you'll see is across workloads, right? You got LLMs, you got recommenders, and across all of them, we have significant perf per dollar advantages. Significant perf, raw perf advantages. It's not just a perf per dollar advantage. It's not because it's cheap, right? Actually, the M7A instances are slightly more expensive, but they give you significantly more performance. So both in terms of performance and performance per dollar, you can see a significant advantage for AMD from top to the bottom here, and significant OpEx savings that you can use to reinvest in. I mean, maybe you need to buy GPU instances to do some training, right? So all of those savings can be funneled to do those things. And that kind of summarizes what I wanted to say about AI. Now I'm going to hand it back to Mike to kind of give you some closing thoughts, right?
Awesome. Thank you, Madhu.
All right. Thank you.
Okay, hey everyone. So it's really pretty simple. The performance on the AMD products, particularly EPYC CPUs, is really, really good. That enables you to drive 27 to 45% OpEx savings for your bottom line. That can keep a number of people employed during the next economic downturn. So you're getting a tremendous cost savings on your application while also enhancing your application performance. That's better product, cheaper cost. Usually those are opposite ends of a seesaw, but in the case of the performance from EPYC, you can really derive some value for it and then reinvest that in innovation or business growth. So thank you for taking the time to join us today. If you would like, please stop by the AMD booth to meet AMD and our partner experts. We can dive into any kind of topics you're talking about, from FinOps to some of the lowest levels of ML inference. If there's any topics, any aspects of what you heard about today that you would like to explore a little bit further, we have these in-booth sessions which we're running through. There's one coming up, actually, looks like we just passed it. Actually, tomorrow there's one coming up from AWS, Unleashing Performance and Efficiency, that is about the cost optimization, although AWS will tell it through their lens. Pixar is going to join us in the morning and Pinterest in the evening. So maybe one of these deep dives would be interesting to you. It's a much smaller setting. We have 12, 15 chairs in the booth, in the AMD booth, and then you have a chance to have a direct conversation with the subject matter experts. And I've been told I shouldn't promote our premier hospitality event at Voltaire tonight because it's already way oversold. But if you really like 50 Cent and you want to try to come see the show, it's probably worth trying to get on the wait list. Press the easy button for cost and performance optimized modernization at scale. Choose AMD EPYC powered instances. If you would like to chit chat a little bit, maybe some small discussion. I know there was a few people with questions and maybe some topics they would like to dig into. Madhu and I will be here for a little while after the session and we can have a conversation, and you can always come join AMD at our booth on the show floor. So thanks very much. Thank you. Thank you. Appreciate you taking the time.